Hello, my dear mechanical champions. Myself, Chandrashekhar, along with Sonu sir, welcome you all to the India's largest, the best, and your favorite live learning platform, BYJU'S Exam Prep. Please do let me know if I'm audible and visible to everyone so that we can start. As you can see over the screen, this is the wonderful session for ESE Prelim 2023. Those who are going to appear for engineering services examination. This is the numerical practice session for thermal as well as applied. So I will take some of the beautiful numericals from the basic thermodynamics, and then Sonu sir will be bringing the questions from the application of the thermodynamics like R&AC, IC engine, power plant engineering. All right. So please do let me know if my audio, video all are fine or not, so that we can start. So I am having around 20 questions from the basic thermodynamics. The session will be around 1.5 hours to 2 hours. So first part is mine and the next part will be Sonu sir. Suraj sir is also there to cheer you up, guys. So this is my quick introduction for those who are here for the very first time. My name is Chandrashekhar, mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in GATE, IES and PSUs. And if you are not part of my Telegram group yet, I would recommend you guys to be part of our Telegram group so that you can get the notes, PDF of all the sessions which we take on YouTube, as well as we will be giving you the updates of different sessions, and the exam notifications will also be provided to you through our Telegram channel only. The link for joining my Telegram group is mentioned over the screen. All right. And important announcement before we just hit the question. So tomorrow, today at 7:30 p.m. there is a mega workshop that is completely free. Abhinav Negi sir will be taking this workshop for all those students who are going to appear in GATE 2024 examination. So he will give you the most important tips and tricks to excel in GATE 2024 examination. You can join or you can register yourself to this workshop, which is completely free. And to register yourself, the link is already there in the description box. All right. Hi Abhi, welcome. Mithun, good evening, welcome. How are you? Shall we start? And if you have appeared for GATE 2023 examination, the rank predictor tool by BYJU'S Exam Prep will be available for you from 15th of February. That is tomorrow. You can check your score, you can check your rank. Accordingly, you can plan ahead of your final score what you are going to get, and you can have a mindset what are all the options you will be having beforehand. It will help you to plan your strategy, plan your preparation for the interview in a better manner. All right. And you can register yourself for this rank predictor tool as well. So let us start with the question number 1. There is a question on the screen, and it is my humble request to each one of you that you should share your answer through the comment section. Even if your answer is not right, it does not matter. But whenever you commit mistake, then you understand what not to do in your actual examination. And calculator don't use the calculator, because it is not allowed in ESE prelims paper. What is the answer to this question? Yes, Krishna, welcome. Abhi, Mithun, everyone. Thermometer is independent of the substance or material used in its construction. Very, very simple question. I hope everyone will be knowing the answer for this. The material or the substance is not important in which of the thermometer. It is the ideal gas thermometer, where the temperature measurement is not a function of the substance, the type of the gas. Yes, option C is the right answer for this question. Good. The next question. Yesterday I was seeing Sonu sir session. he had discussed this question in yesterday's session as well, the mock test. Yes, the following examples are some intensive, or we can also call them intrinsic properties, and extensive or extrinsic property. Extensive properties are which depends on mass or the extent of the system. Intensive, independent of mass. So you need to find out which of them are intensive, which one of them are extensive. Yes, pressure, is it intensive or extensive? Temperature, is it intensive or extensive? Volume, it is intensive or extensive? Velocity, is it intensive or extensive? Electrical charge, it is intensive or extensive? You need to find out, or the options are there on the next page. So you need to find out which one of the following options are correct for intensive and extensive properties. All right. Magnetization, that is also extensive. Viscosity, independent of mass, and energy, all forms of energy are extensive properties. So intensive properties are 1, 2, 4, and 7. Isn't it? 1, 2, 4, 7. 1, 2, 4, 7 are intensive properties, and rest of them are extensive properties. What is the answer to this one? Yes, Abhi. Well done. Keep it up. Everyone, please check. Temperature, pressure, viscosity, and velocity, they are independent of mass. Rest of the properties are extensive properties. This was question number 2. Let us move to question number 3. Yes, question number 3. So please do revise all the concept which you have studied throughout the year. The revision is very, very important for clearing or for getting good marks in ESE examination, because you will find the questions from each and every corner. There are 150 questions in total. So there is a fair chance that from each and every corner there will be question. Maybe easy, maybe tough, but you will find the questions from each and every corner. And for correcting those questions, you need to revise all the subjects thoroughly before going for the examination. Yes, next question. Question number 3. Question number 3 says, in list 1, the type of the thermometer, and list 2 says the thermometric properties. What are thermometric properties? Which helps in determining the temperature. Mercury in glass, it is the volume or the length, because due to heating or due to temperature rise, there is a expansion in the mercury. So it is the volume. Mercury in glass, the thermometric property is volume. A3, 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 A3. You can rule out the options which cannot be possible. A and C cannot be possible. A and C cannot be possible. Thermocouple. In thermocouple, it is the electrical resistance. B2, 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 B2. D is also incorrect, isn't it? B2. Acha, sorry. In thermocouple, it is the voltage, not the electrical resistance. Thermocouple is voltage. Thermocouple, it is the voltage difference which determines the temperature. So B4, 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 B4. B cannot be true. Then thermistor or resistance thermometer, it is the electrical resistance. For C, it is 2, C2, and D, constant volume gas thermometer. Pressure is the thermometric property. If the volume is constant, so we can say pressure is directly proportional to temperature. So constant volume gas thermometer, pressure is the thermometric property. Option D is the correct answer. Abhi, option D, isn't it? Option D. 3, 4, 2, 1. Isn't it option D? Right? The next question. The next one, question number 4 on your screen. When a system is taken from state A to state B along the path ACB, 180 kilojoule of heat flows into the system. Heat added into the system is positive. So QACB is equal to plus 180 kilojoule, and it does 130 kilojoule of work. Work done by the system WACB is equal to 1 plus 130 kilojoule. Signs are important. Sign convention is very, very important. How much heat will flow into the system along the path ADB, QADB, if the work done by it along the path is 40 kilojoule. WADB is, what is the answer? What is the answer? WADB is given as plus 40 kilojoule. Yes. What is the answer? Everyone, please give it a try and let me know. If we apply first law of thermodynamics, or we can say Q is equal to delta U plus W. Q is equal to delta U plus W. Q is equal to delta U plus W. Can you solve it? So Q minus W, because delta U will be same. Delta U for both the initial point is 1 for both the processes, and the final point is B. Because the initial and final points are same, so the internal energy is a property, or internal energy is a point function. So Q minus W for ADB should be equal to Q minus W for ACB. So can you find out QADB? What is the answer? If the question asks you to find out the change in internal energy, that is also you can find out. So option C is the right answer, 90 kilojoule. Shall I solve it? So QADB minus WADB, that is minus 40, is equal to QACB, that is 120, minus WACB, that is 130. So QADB will be equal to 50 plus 40 kilojoule, that is 90 kilojoule, right? It is 90 kilojoule. Option C is the correct answer. Read the next question and try to get me the answer for the next one, everyone. बाकी लोग कहाँ हैं? Krishna, read the question and try to find out the answer. You should always read the question very carefully, because you might commit silly mistake in hurry. A gas expands from the pressure P1 to pressure P2. There is an expansion of the gas. If we draw the process on PV diagram, then it is expansion process. P2 is P1 by 10. Let me call this as P1 and let me call it as P2. That is equal to P1 by 10. So the gas is expanding. If the process of expansion is isothermal, the volume at the end of expansion is 0.55 meter cube. If the process of expansion is adiabatic, the volume at the end of the expansion will be close to. So this is point 1. If it is, can you draw the curve for isothermal? So the slope of dP by dV for isothermal is less than the slope of adiabatic. The slope of isothermal curve on PV diagram will be less than the slope of adiabatic curve, isn't it? So the isothermal process will be something like this. This is T is equal to constant, and adiabatic process will be something like this. Expansion, it is the expansion curve. So if this is 0.55, this point will be less than 0.55 only. It will be less than 0.55. So only one option is available, which is less than 0.55. Adiabatic process will be having more slope compared to isothermal process, isn't it? So adiabatic process will be steeper compared to the isothermal process. Isothermal process will be flat comparatively. So from here we can find out we cannot find out the exact value, but yes, it will be less than 0.55. Yes, Krishna. Option A is the correct answer. Well done. Good, good, good. The next question on your screen. Match the column. In list 1, there are various processes, and in list 2, index n. In the expression PV to the power n is equal to constant. Select the correct answer using the codes given below in the list. For an adiabatic process, isothermal, constant pressure or isobaric, as well as constant volume process. Simple question. So if we draw the curve, pressure versus volume, this is constant pressure, this is constant volume line. This is volume. This is the pressure. So the curves will be something like this. Like this. So this is constant temperature, isothermal, and for isothermal PV to the power n is equal to constant. For isothermal n will be equal to 1, and this is adiabatic, Q is equal to 0. This is adiabatic, and for adiabatic process n is equal to gamma, isn't it? That is equal to Cp by Cv. And this is constant volume process, n is equal to 0. For constant volume, n will be equal to 0. And for constant pressure, n is equal to infinite. This represents expansion, and this is the compression region. This will be the compression and this will be the expansion. So we can find it out. For constant volume, K is equal to n is equal to 0. For adiabatic, n is equal to Cp by Cv, A2, C cannot be true. Isothermal, n is equal to 1, B3, D is ruled out. Then constant pressure, n is equal to infinite, C1, constant pressure. For constant volume. For constant volume, C is equal to 5. For constant pressure, for constant pressure, yes, n is equal to 0. For constant pressure, n is equal to 0. For constant pressure, n will be equal to 0. गड़बड़ कर दी ना मैंने. For constant pressure, n will be equal to 0, and for constant volume, n will be infinite. This is actually constant volume process. Vertical line is constant volume process. And horizontal line is constant pressure process. N is equal to infinite. Sorry, my mistake. Yes, for constant volume, n is equal to infinite. क्या कर? This is how it will be represented. Horizontal line will be constant pressure process. For constant pressure, n will be equal to 0. And vertical line represents the constant volume process. For constant volume, n will be equal to 1 by 0. N will be equal to 1 by 0. Right? Now it is correct. अब ठीक है? So it will be option constant pressure, n will be equal to 0. So C5, and constant volume n is equal to infinite. B is the answer for this one. B will be the answer, isn't it? Is it A or B? Question number 6. B will be the answer. B बोला क्या? किसने B बोला? Yes. The next one. Let us move to question number 7 here. Question number 7. Read the question. हाँ बताइए क्या? कृष्णा कुछ कंफ्यूजन है? देखिए पीवी टू द पावर एन है. अगर पीवी एन की वैल्यू 0 पुट कर दे तो v की पावर 0 विल बी इक्वल टू 1. What is the value of v to the power 0 that is equal to 1? Implies pressure is constant. So for constant pressure process, n will be 0. For constant pressure process, n will be equal to 0. And pv to the power n is equal to constant. If we want constant volume process, then what we can do? We can take the power 1 by n here, 1 by n. So p to the power 1 by n into v is equal to constant to the power 1 by n is again another constant. So we want 1 by n to be 0. We want 1 by n to be 0 for constant volume process. So 1 by n will be equal to 0. So we can say n will be equal to, if 1 by n is equal to 0, then it will become constant volume process. For constant volume process, n will be infinite, isn't it? Isothermal के लिए isothermal process is PV is equal to constant, that is isothermal process. For isothermal process, n is equal to 1. And for adiabatic, PV to the power gamma is constant. So n will be equal to gamma, that is Cp by Cv. Right, Krishna? Clear? अगला क्वेश्चन पढ़िए और सॉल्व करके बताइए. दिस इज ब्यूटीफुल क्वेश्चन. द क्वेश्चन इज फ्रॉम द पॉलीट्रॉपिक प्रोसेस, असर्शन एंड रीजनिंग. Though heat is added during a polytropic expansion process for which gamma is greater than n, n is the polytropic index, greater than 1. The temperature of the gas decreases during the process. Is the assertion correct or not? So Q for a polytropic process is given by M, C for polytropic process into delta T, or we can write it as dt. So where C poly will be equal to, C for polytropic process will be equal to n minus gamma upon n minus 1 into Cv. So if you see this is less than 1, this is negative because n is less than gamma. So n minus gamma will be negative. So this value will be negative. So if Q is positive, heat is added, then delta T will be negative. So the temperature will decrease. Heat addition will give rise to decrease in temperature, and heat rejection will give rise to increase in temperature. For a polytropic process, heat addition will give rise to decrease in temperature, and heat rejection will give rise to increase in temperature. So the temperature of the gas will decrease during the process, heat addition. So assertion is correct. And if we talk about the reason, the work done by the system exceeds the heat added to the system. If we talk about the work done, what is the work done in a polytropic, or we can say Q can also be written as Q for polytropic process is equal to M into C poly into delta T is equal to gamma minus N upon gamma minus 1 into W for polytropic process, and where W for polytropic process will be equal to P1 V1 minus P2 V2. It will be P1 V1 minus P2 V2 upon N minus 1. Right? So this is positive value. This is positive. And that is greater than, this is greater than 1. That is greater than 1. So if this is greater than 1, then Q poly will be greater than W poly. The work done by the system, reason, sorry, So work done. Because gamma is greater than n is greater than 1, the work done by the system exceeds the heat added to the system. Yes, work done is greater than, because Q is equal to W plus delta U, because the temperature is decreasing, so this is decreasing, delta U will be decreasing. So that is why work done is greater than Q, heat supply. Yes, so option A is the correct answer. Assertion and reason are individually true, and the reason is the correct explanation for the assertion. That is why during the heat addition, the temperature decreases. So option A is the right answer. Option A will be the correct answer. And you as all know, other than technical, there is a non-technical syllabus in ESE prelims exam. So the Maha Marathon session is already running on the BYJU'S YouTube channel for non-technical portion as well. So do subscribe the YouTube channel if you have not, and do join these free sessions which will help you to improve your score in your ESE prelims examination. All right. And on 19th of January or 19th of Feb, we will be coming live after the examination for the analysis of ESE exam. Paper 1 analysis will be at 5 p.m. and paper 2 will be at 6 p.m. All right. So do join this analysis session to check how your exam went. And we will discuss the cutoff marks. We will discuss the expected difficulty level as well. The next question on the screen. Next question, question number 8. I am having around 20 questions. Question number 8 on the screen. This is from the first law applied to the steady flow devices. List 1 are the steady flow devices. And list 2 is the first law. Thermodynamic equation. That is the first law for thermodynamics. That is H1 plus T1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. Yes, match the column. Turbine is a work producing device. Turbine is a work producing device. So there is no change in potential energy. There is no change in kinetic energy. Change in potential energy is equal to change in kinetic energy is equal to 0. And if the turbine is thermally insulated, Q will be equal to 0. So it is work producing device. So turbine will be W is equal to H1 minus H2. W will be equal to H1 minus H2. A4. A4. Nozzle. In case of a nozzle, C2 is very, very large compared to C1. C is the velocity. C is the flow velocity. I am using the notation C for the flow velocity. C2 is very, very large compared to C1. There is no change in potential energy. Q will be equal to 0. So for a nozzle, H1 is equal to, we can ignore C1. So for nozzle 3, B3, B3, B3. And valve, isenthalpic, throttling valve is isenthalpic. Throttle valve, isenthalpic, there is no change in potential energy, there is no change in kinetic energy, there is no heat flow, there is no work done. So valve, for a valve, H1 is equal to H2, C2, C2. Option A is the correct answer. And D, compressor is a work consuming device. So it will be H1 minus H2. Work done for a compressor is negative. Work done for a turbine will be positive. Sorry, this is for turbine and this is for compressor. 1 is for compressor, H2 minus H1, and 4 is for turbine. Option A is the correct answer. Right? Option A. The next one, question number 9. sorry, question number 9 is this. Can you solve this one? Question number 9 on the screen. It is PV curve. The net work done for a closed system undergoing a cycle shown in the figure, pressure versus volume diagram is. What is the work done? What is the net work done for the cycle A, B, C, D? Can you solve it? This is question number 9. We are having 20 questions. Then Sonu sir will bring another 20 questions. For a cycle, the work done is the area under PV curve or area enclosed by the cycle. Net work done will be the area enclosed by the cycle. Can you find out the area? Pressure is in bar, volume is in meter cube. So bar is 100 kilopascal. So if you see, the height of triangle ABC is 2 and the height of triangle ACD is 3. So if we write work done is equal to half into base, this base is 4 meter cube into height, that is 200 kilopascal, plus half into base is again 4 into 300 kilopascal. This is kilojoule or kilonewton meter. So do the calculation. That is equal to 400 plus 600. That is 1000 kilonewton meter. Option D is the answer. 1000. Yes, it is option D. The next one, question number 10. There is a volume versus temperature curve is given for the cycle. You need to represent this curve on PV diagram. You need to represent this cycle on PV diagram. If you see AB process, A to B, volume is directly proportional to temperature. It is a straight line. So AB is constant pressure process. AB is constant pressure process. A to B is constant pressure. This cannot be correct. AB is constant pressure. It is constant volume. AB is constant pressure process. This is also incorrect. If volume is directly proportional to temperature for an ideal gas, then it means it is isobaric process. Only option possible is D. AB is constant pressure, heat addition. So the temperature is rising. Heat addition, constant pressure, heat addition is constant pressure expansion. So there is an expansion. B to C is constant volume process. So pressure is directly proportional to temperature. B to C is constant volume process. B to C is constant volume process. And C to A is constant temperature or isothermal process. C to A is isothermal. D is the answer for this. Option D is the correct answer. You should be able to represent a cycle on one curve into another curve. The next question, question number 11. The next one, question number 11. If integration of PdV is and integration of VdP for a thermodynamic system of an ideal gas on valuation gives the same quantity, it is quantity, same quantity during a process, then the process undergone by the system is. So for an which curve? For an isothermal process, closed system work will be equal to open system work. Integration of PdV will be same as integration of VdP, isn't it? Or minus VdP. So closed system work and open system work will be same. अच्छा कराया था क्या? अच्छा, अगला क्वेश्चन बताइए. क्वेश्चन नंबर 12. First law of thermodynamics is valid for the next one. First law of thermodynamics is valid for. Tomorrow we will have the practice session for fluid mechanics and heat transfer. Tomorrow there will be practice session for fluid mechanics and heat transfer. First law of thermodynamics is nothing but energy conservation. It is energy conservation. So it is valid for all type of processes. It is valid for all type of processes. Reversible as well as irreversible. It is valid for a process also. It is valid for a cycle also, because it is the energy conservation which is universal law. The next question, question number 13. Beautiful question. Question number 13 on the screen. An ideal gas is taken through 3 processes, as a result of which the final state is identical with the initial state. It means it makes a cycle, thermodynamic cycle. The nature of the processes, work done and heat transfer during the processes are as follows. 1 to 2 is constant volume process. 1 to 2, volume is constant, with a heat input of 50 kilojoule. Q is equal to 50 kilojoule, heat is added. And if it is constant volume, so work will be equal to 0. W will be equal to 0. And Q is equal to delta U. Then 2 to 3 process is an isothermal, temperature is constant. Isothermal expansion, and the work done by the system is 500 kilojoule. Work done by the system is 500 kilojoule. Here delta U will be equal to 0. So W is equal to Q. Work done is equal to heat addition. And 3 to 1 process is constant pressure. Pressure is constant for 3 to 1. And the work done on the system, W is equal to minus 200 kilojoule. Then what will be the heat transfer and the change in internal energy during the process? 3 to 1. So what is Q for 3 to 1 and change in internal energy from 3 to 1? What is the answer? So for a thermodynamic cycle, net heat transfer is equal to net work transfer. First law for a cycle. If we apply first law for a cycle, sigma Q is equal to sigma W. From here we can find out W. From here we can find out W. Can you find out W? 50 plus 500 plus Q. 50 plus 500 plus Q, 3 to 1 is equal to 0 plus 500 minus 200. This 500 getting cancelled out. So Q 3 to 1 is equal to minus 250. Once you find out Q 3 to 1, then you can find out delta U. So Q 3 to 1 is equal to delta U for 3 to 1 plus W 3 to 1. So this is minus 250 is equal to delta U plus W 3 to 1 is minus 200. So delta U will be equal to minus 250 plus 200, that is equal to minus 50. First law of thermodynamics. So Q will be minus 250 and delta U will be minus 50. Minus 250 and minus 50. Signs are very, very important. Take care of the sign convention. Otherwise, you might end up committing mistake. The next one. Question number 14. Question number 14 on the screen. Find out the answer for question number 14. A balloon containing an ideal gas is initially kept in an evacuated and insulated room. Q is equal to 0, thermally insulated, and evacuated means free expansion. It is vacuum. Vacuum does not offer any resistance. It is the free expansion. So W is equal to 0. The balloon ruptures and the gas fills the entire room. Which one of the following statement is true and at the end of the above process? So it is the free expansion against vacuum, which does not offer any resistance. So work done will be equal to 0. Q is equal to 0. And from the first law of thermodynamics, delta U will be equal to 0. And because it is an ideal gas, U and H are a function of temperature only. For an ideal gas, U and H are functions of temperature only. So we can say if delta U is equal to 0, it means the temperature is constant. Then we can say delta H will also be equal to 0. Internal energy and enthalpy change will be 0. Both the internal energy and enthalpy will remain same, isn't it? Both the internal energy and enthalpy will remain constant. There is no change in internal energy. There is no change in enthalpy of the system. Question number 15. Question number 15. A fluid which is flowing along a pipeline undergoes a throttling process. What is throttling? Flow through a restricted passage. And for throttling, it is isenthalpic. Isn't it isenthalpic? Throttling is isenthalpic process. H1 is equal to H2. Enthalpy remains constant. And it is expanding from, it is flowing from 10 bar to 1 bar, passing through a partially opened wall. Before throttling, specific volume is 0.5 meter cube per kg, and after throttling, specific volume is 2 meter cube per kg. What is the change in specific internal energy? So we can say U1 plus P1 V1 is equal to U2 plus P2 V2. What is the change in specific internal energy? So U2 minus U1 is equal to P1 V1 minus P2 V2. P is the pressure, V is the specific volume. Find out the value. It is 10 bar. We need to find out in kilojoule per kg. What is V1? That is 0.5 minus P2 1 bar, that is 100 kilopascal, into V2, that is 2. That will give you the answer. (500 minus 200), that is 300 kilojoule per kg. Yes. Right, 300 kilojoule per kg. Option D is the correct answer. Option D. Question number 16. Question number 16. An engine, heat engine, reversibly receives 1200 joule of heat at 900 Kelvin. This is 900 Kelvin. This is heat engine. It is receiving 1200 kilojoule. Sorry, 1200 joule of heat. After rejecting heat to the ambient at 300 Kelvin, this is 300 Kelvin, it develops 600 joule of work. Work produced is equal to 600. So Q2 will be equal to 600. From the first law of thermodynamics. The irreversibility in joule is equal to, what is irreversibility? That is T naught, ambient temperature, this is T naught, into delta S for the universe. There is no change in internal, there is no change in entropy for the engine. So universe means source and the sink. It is an isolated system. We can call it as isolated system. So T naught is 300. So we can say delta S for the source plus delta S for the sink. 300 Kelvin multiplied by heat is rejected from the source. So entropy will decrease. So it is minus Q1 by T1. Heat is added to the sink. So entropy will increase. So plus Q2 by T2. Put the values, you will get the answer. 300 minus 1200 divided by 900 plus Q2, that is 600 by 300. What is the answer? Question number 16. What is the answer for question number 16? Irreversibility is equal to, this is the formula you are supposed to remember. So the answer to this question is option C. C will be the answer. C will be the answer. Right? The next one, question number 17. I am having 3 more questions after this. Then Sonu sir will be discussing the questions from the applied thermodynamics. A heat pump which operates in a cycle extracts heat energy from the cold reservoir. This is the cold reservoir, and supplies the same amount of energy to the hot reservoir. This is the hot reservoir. Which one of the following statements holds for this process? So if this is Q, this is also Q. There is no work done on the system. So according to first law of thermodynamics, it is correct. The energy in is equal to energy out. So it does not violate this process, does not violate the first law, but yes, it violates the Clausius statement of second law of thermodynamics. It will violate the Clausius statement of second law of thermodynamics because according to Clausius statement, heat cannot flow from low temperature reservoir to high temperature reservoir without any external work. So if work done is zero, the process cannot be possible. So this process violates the second law but not the first law. Option C is the answer for this one. Option C is the correct answer. Question number 18. From the Maxwell relation, you can develop the Maxwell relation using the thermodynamic square. Do you remember this? Del P by del T at constant entropy is equal to which one of the following options is correct? Using the thermodynamic square, you can memorize. I hope you know thermodynamic square. Good professors have studied under very fine teachers. Good professors have studied under very fine teachers. So del P by del T, this is equal to at constant del P by del T. It must have been. It should have been constant volume. Then it will be del S by del V at constant pressure. यहाँ थोड़ा सा गड़बड़ हो गया ना. C and D are same. Yes. Del P by del T at constant volume should be equal to del S by del V at constant temperature. It should have been the temperature. And when S and P are coming together, we should put negative signs. So, थोड़े options में गड़बड़ हो गई है, but del P by del T at constant volume should be equal to del S by del V at constant temperature. Option A would have been correct. Next one, question number 19. On a TS curve, the slope of constant volume line for an ideal gas is. On TS curve, the slope of constant volume line. So for a constant volume line, slope dt by ds for a constant volume is equal to T by CV. dt by ds for constant pressure is equal to T by Cp. And Cp is greater than Cv. So constant volume line will have more slope than the constant pressure line. Constant volume will have more slope. This will have more slope because Cv is less. This is less. Isn't it option B? Constant volume line will have more slope. B. It is B. Constant volume will have more slope than the constant pressure line. And this question is your assignment. This is your assignment question. And now let us see if Sonu sir is there or not. Hello sir, are you there? Students are waiting. So let me stop here only. I will share the PDF of this session to my Telegram group and enjoy the remaining portion of the thermodynamics, that is applied thermodynamics. That is again very, very important for your ESE examination. All right. If anybody is having anything to ask, you just let me know. Otherwise, do not forget to like this session so it reaches to all the students who are preparing for this. Yes, Sonu sir is all ready. So let me take your leave. Enjoy, take care, have a good day and a great future ahead. Thank you guys. Thank you very much. Over to you, Sonu sir.
So very good evening to all of you. I hope you are doing great. और before starting the session, just let me know is my audio video fine or not. और उसके बाद हम start करने जा रहे हैं applied thermodynamic. You know very well. In this session, we are going to discuss the entire thermal. Basic thermodynamic is already completed by sir. उसके बाद जो applied thermodynamic का portion बचा है, let's start the topic, my dear. Avi and all of you, yes, share the session, my dear, with your friends. Very good evening. और उसके बाद चलिए हम आज का session start करते हैं यहाँ से. So let's start the things. Till now you have discussed 20 important questions of basic thermodynamic. 20 more important questions we are going to discuss from here that is related to the applied thermodynamic. Let me tell you before starting the session, applied thermodynamic means we are going to discuss the IC engine topic, refrigeration topic and psychrometric topic and the power plant, my dear. Each and everything we are going to cover here from the basic level to the applied thermodynamic. तो चलिए स्टार्ट करते हैं सेशन को. दिस इज ऑल अबाउट मी. बहुत ज्यादा देर यहाँ पे नहीं रुकते हैं, अपना मेन क्वेश्चन से स्टार्ट होते हैं. बट बिफोर दैट ए फ्री वर्कशॉप अगेन, अ वेरी इंपॉर्टेंट वर्कशॉप माय डियर, दैट विल बी कंडक्टेड बाय जोसेफ सर. टॉपिक विल बी कंप्लीट रोड मैप टू गेट AIR under 100 in gate 24. If your target is gate 24, then you all dear my friend, all my dear friend, then definitely you must join. Date will be 18th of Feb and time will be 7:30 PM. Okay. First question on your screen related to the Carnot cycle. Let's see how many of you are able to write the correct answer of this question. What exactly the question says, my dear, that Carnot cycle that use the nitrogen as a working fluid, nitrogen as a working fluid, gamma is equal to 1.4 given in this question. The heat supply is 52 kilojoule, okay, and the adiabatic expansion ratio is 32 raised to 1, my dear. Then the receivable temperature means simply a sink temperature. If the sink temperature is 295, then what will be the amount of the heat that will be rejected from the system? Question is purely mentioned here. It is purely the example of the Carnot cycle. In the Carnot cycle, my dear, T1 higher temperature is not given to me. That is the heat engine, my dear, that is producing the work done, and T2 is given to me. How is the value of, how much is the value of T2? That is 295 Kelvin. Okay. Q1 is given or not? Yes, Q1 is given, that is 52, my dear. Then in this case, what will be the value of the Q2? This is the question. So first of all, what exactly we need to know? What we need to know, that is the higher temperature, first of all. And second one, my dear, I need to know what is the Q2. And if I will draw the TS diagram, let me change the color of this pen so that you will be able to view these all the points clearly. If I draw the PV diagram, my dear, then on this PV diagram, this one is a isothermal process where T1 is equal to T2. This one, my dear, adiabatic expansion ratio. And in this process, let me tell you, in this process 2 to 3, this expansion ratio is given to us. After that, isothermal compression, then adiabatic compression, like this, my dear. Okay. So what exactly given? This lower temperature given to us. Calculator can I use? No. Without calculator you need to find the answer. Calculator allow ही नहीं है. Okay. So how you will find? In this case, my dear, this expansion ratio is given, that is given like this. V3 by V2, my dear. This expansion ratio given to us, that is 32. T1 is also given to us. T2 is also given to us. That is equal to, my dear, how much is the value? Or we will write this, T lower is given to us. That is 295 Kelvin. Correct? Now, if we want to find from here that higher temperature, this one is the higher temperature and this one is the lower temperature. So can we write T higher temperature divided by T lower temperature will be equal to R raised to gamma minus 1. पढ़ा है कि नहीं पढ़ा है हमने अभी? Yes. What is the value of R? R is 32 and gamma minus 1, it means 0.4, and this will be equal to 32 and this 0.4 will be equal to 0.4 by 10, or this will be equal to, my dear, 32 raised to 2 by 5. Is it or not? So it can be written like this, 2 raised to 5, 2 raised to 5 raised to 2 by 5. If I solve, we are getting 2 raised to 2, then T higher divided by T lower, my dear, it is the ratio of 4. Getting or not? In this case, without calculator, you can easily get the ratio of T higher and T lower, it is equal to 4. And we know very well that H per the Carnot cycle, we have already studied that heat supply divided by heat rejected is also equal to T higher divided by T lower. ये तो हमने पढ़ी. It is equal to 4. So from here we know very well that is the value of the 52. This is the heat rejected will be equal to 4. From here we can write T heat rejected will be equal to 13. Na? 13. 13 kilojoule will be the answer. It is the cycle definitely change of internal energy will be 0. Total internal energy will not be 0. Change of internal energy will be 0. 13 B for Bombay is the correct answer of this question, my dear. Chaliye, let's move forward and see the answer of this question. In a heat engine, operating in a cycle between the source temperature and sink temperature, what will be the least rate of the heat rejection per kilowatt of? फिर से same question है. Again, it is the example of the Carnot engine. Sir, you may ask why it is the Carnot engine. This is T1. This one is the heat supply, my dear. And this is the heat engine. And again, there is the heat rejection. And this will be the T lower. That will be the value of T2, my dear. Work, it will be somewhere like this. You must ask, sir, इसमें कहीं ऐसा लिखा नहीं है, तो हम कैसे कह सकते हैं it will be a Carnot cycle? Sir, it is written clearly that you want to reject the least amount of the heat. Means you want the maximum amount of the work output, and that is only possible when it will be the problem of the reversible heat engine or the problem of the Carnot cycle. Okay, so can we write from here like this? That efficiency of the Carnot will be equal to 1 minus T2 divided by T1, my dear. It is also equal to 1 minus Q2 divided by Q1. So in this case, T2 divided by T1 will be equal to Q2 divided by Q1. T2, how much is given, my dear? T2 is this 606. What will be the value? 606. What will be the value? T2, 20. That is 293. And what is it? That will be equal to 879. Absolutely right. And this is Q3 or Q2, and that is Q1. Are we not getting 1 by 3? 1 by 3. So what is the, yes, so in this case we can say that Q2, yes, Q2 will be equal to Q1 by 3, right? So for 1 kilowatt, if we write from here, then we can write W will be equal to Q1 minus of Q2, and W what exactly I want? 1 kilowatt. So what is the value of the Q3 we need to find? यहाँ से बहुत आसानी से अब आपका आंसर आ जाएगा. Heat supply पूछा है या heat rejected पूछा है? Okay, heat rejected it ask. So Q1 will be equal to 3Q2 minus of Q2. That will be equal to 2Q2. It will be 1, or Q2 from here it will be 0.5. 0.5 आ रहा है. It's not, हाँ, exactly, yes, absolutely right. 0.5 is the correct answer. Yes, 293, absolutely right. Even the same formula what you have written now, we can also go with this formula also. ये भी सही formula है. You can also go with this formula directly, and first you can find the value of Q1 and second you can find the value of Q2. बिल्कुल सही आंसर है. This will be the correct answer of this question, my dear. ये स्क्रीन को क्या हो रहा है? अच्छा, अब सही है. Okay. Yes. So the next question is this one. Important question is there, my dear. Generally, you have studied what you have discussed the PV diagram, what we have studied the TS diagram, बहुत सारे problem पढ़े होंगे, but these are some advanced question. It is clearly asked that Otto cycle is given to us, my dear. Then what will be the Otto cycle diagram? Okay. Maybe. ये तो यार क्या तुम इसमें कर सकते हो. चलिए, anyway, write the correct answer of this question, my dear. Yes, Otto cycle is given. It will be better, first of all, you will draw the PV diagram of this entire problem, my dear, so that you will get the clear-cut idea that how this process exceed 1 to 2, in which pressure increasing, temperature is also increasing, both are increasing. 2 to 3, pressure, temperature, both are increasing, but in a linear way, because the volume is constant. 3 to 4, both are decreasing, and 4 to 1, both are decreasing in a linear way. Means if I will draw this 1, 2, 3 and 4, like 1, 2, 3 and 4, like this 1, 2, 3 and 4, like this 1, 2, 3 and 4. Oh, ये तो उल्टा हो गया. देखिए एंटी क्लॉकवाइज, is it possible or not? Not possible. Let's discuss one by one. In 1 to 2 process, my dear, pressure and temperature both are increasing because it is the example of adiabatic process. Check any process in which pressure and temperature both are increasing. Pressure and temperature. In this one, pressure, temperature both are not increasing. In this one, if I talk about this, yes, pressure and temperature, pressure is increasing, temperature constant. It is going to hint me that it is the isothermal process, but in the Otto cycle there is no isothermal process. That's why it is not the answer. Now come to this particular process, my dear. 1 to 2, sir, pressure is increasing, temperature is also increasing. 2 to 3, linear process of isochoric. 3 to 4, pressure is decreasing, temperature is also decreasing, my dear. And 4 to 1, both are decreasing. 4 to 1, both are decreasing, pressure decreasing and temperature is also decreasing. Answer of this wonderful question is A. Yes, lag nahi raha hai, wahi answer hai abhi. Next, Otto cycle is given on this problem. Then these are the 4 important process, my dear, where the internal energy and entropy is changing. So you need to select the proper diagram. What is the proper diagram of this entire problem, my dear? Okay, this one, like this one. Chaliye, tell me the correct answer of this question. Internal energy versus entropy diagram is given to us. Let me tell you, my dear, 1 and C will never be the answer. Do you know? ये कभी ऑटो साइकिल का आंसर होगा ही नहीं. क्यों? क्योंकि 1A और C में हमको क्लियरली दिया हुआ है. नहीं ये आपको बिल्कुल कार्नोट जरूर लग रहा होगा, लेकिन कार्नोट में हम टेम्परेचर और एंट्रोपी का डायग्राम बनाते हैं. Here we are talking about the internal energy and entropy. So 1A and C will never be the answer. Do you know why? Because, my dear, in this process now, in A and C, it is clearly mentioned that internal energy remain constant, which is impossible in Otto cycle. क्योंकि internal energy is the function of temperature और temperature कभी होता नहीं constant. So A and C is absolutely wrong option. Let's come to this part, my dear. One process is the isentropic process, entropy remain constant. Yes, it is valid. One process is the isentropic process. Yes, it is valid. Expansion and the compression process is the isentropic process. B is the right answer. Even in the D option, entropy does not remain constant. That is the reason it is also incorrect option, my dear. Okay, so B is the correct answer. Next, in order to a value of the thermal efficiency of the Otto, diesel and dual cycle when they have the equal compression ratio. Yes, Abhi, point is very clear. Sir, in Otto cycle we know very well that 2 are the isochoric process and, my dear, other 2 are the adiabatic process. And in adiabatic process, entropy remain constant. So first of all, we must know that this and this will never be the process, because in both the process, entropy is not constant in all process, in at least 2 process. सो अब ऑप्शन बचा या तो ये या तो ए, बट ये भी नहीं हो सकता. डू यू नो व्हाई इट इज नॉट पॉसिबल? बिकॉज इन ऑटो साइकिल देयर इज नो चांस ऑफ इंटरनल एनर्जी रिमेन कांस्टेंट. सो ए इज नॉट आंसर, सी एंड डी इज नॉट आंसर, ओनली बी इज द करेक्ट आंसर. Because in V, both the conditions satisfy. What is the first condition? Entropy constant in adiabatic compression and my dear expansion. What is the second condition? Entropy constant, but internal energy can never be the constant because in all the process there is no isothermal process in Otto cycle. Okay. Yes. Next question. Question number 5. Question number 5, my dear. In order to the value of the thermal efficiency, diesel and dual cycle and Otto when they have the equal compression ratio. सर ये क्वेश्चन हम कल भी करके आए थे, मतलब ये नहीं था, सिमिलर क्वेश्चन. In other way we have discussed gamma minus 1 and efficiency of the diesel cycle 1 minus 1 upon r raised to gamma minus 1 into rho raised to gamma minus 1 divided by gamma into rho minus 1. Is it or not? So it is clearly given. Otto will have the maximum, dual then after that diesel, because bracket term is more than 1. That's why Otto cycle for the same compression ratio will have the maximum efficiency. Come back to the question number 6. In practice, efficiency of the efficiency of the diesel engine is greater than the efficiency of the petrol engine. This is the assertion in practical condition. सही भी है. दूसरा स्टेटमेंट दिया है, for the same compression ratio, efficiency of the diesel engine is higher than that of the Otto cycle. अभी अभी करके आए हो, गलत नहीं कर सकते. एक पार्ट अभी जस्ट करके आए हो इसमें. R is absolutely wrong, my dear. So there is the option where R is wrong. That is the option C. Yes, A is true, but R is false. Next. A gas turbine with infinite number of the compression and the expansion stage, my dear. A gas turbine having the infinite number of compression and the expansion stroke. Yes, तब ज्यादा प्रॉब्लम होती है. एग्जैक्टली मैक्सिमम टाइम प्रॉब्लम तभी होती है जब आपके दोनों सही हो जाएं, बिकॉज एट दैट टाइम इट इज क्वाइट डिफिकल्ट टू फाइंड द डिफरेंस बिटवीन ए एंड बी ऑप्शन. यस, क्या लिखा हुआ है सर? इनफाइनाइट नंबर ऑफ द कंप्रेशन स्ट्रोक, लाइक दिस वन इज द कंप्रेशन. सो इफ आई विल हैव द इनफाइनाइट नंबर ऑफ द कंप्रेशन स्ट्रोक लाइक दिस, compression stroke like this, after that this one is the pressure constant, infinite number of the expansion stroke like this, and after that there is the process. So when this will be infinite now, then this height will start to decrease and it will be converted into a line. That in this case you can say temperature is constant, and in this case you can say that temperature is constant when the infinite number of stages will be there. मतलब क्या है? We are talking about such a cycle which is having two process as a isothermal and other two process as a isobaric, और उसका एक ही नाम आता है, that is the Erikson cycle. Erikson cycle is the cycle in the starting time जिसमें दो प्रोसेस आपके आइसोथर्मल होते थे और बाकी के दो प्रोसेस आइसोबैरिक होते थे. स्टर्लिंग साइकिल इज द साइकिल जिसमें दो प्रोसेस आइसोथर्मल होते थे और बाकी के दो प्रोसेस आइसोकोरिक होते थे. ठीक है, चलिए थोड़ा सा नॉकिंग डेटोनेशन भी पढ़ लें. आईसी इंजन का बड़ा ही इंपॉर्टेंट पार्ट है. जब आप ईएससी लेवल की बात करते हो, ईएससी लिखने जा रहे होते हो, डेटोनेशन एंड नॉकिंग इज अ क्वाइट इंटरेस्टिंग टॉपिक इन आईसी इंजन. Which of the following factor increase the detonation in IC engine? I mean SI इंजन, स्पार्क या फिर पेट्रोल इंजन में कौन कौन से पर्टिकुलर पार्ट हैं जो एक्चुअल में डेटोनेशन बढ़ाते हैं? एनीवन? डी इज द आंसर, 1 and 4. आपका कहना है डी आंसर होगा. इंक्रीज द स्पार्क एडवांस, एब्सोल्युटली. पहले से ही अगर इसको एडवांस कर दोगे तो डेफिनेटली आपका डेटोनेशन होगा, क्योंकि लार्ज में यस. इंक्रीज द एयर फ्यूल रेशियो, मतलब अगर आप लीन मिक्सचर बनाते हो नहीं करेगा. इंक्रीज द स्पीड, ये नहीं करेगा डेटोनेट. जितनी फास्ट साइकिल रखोगे उतना कम टाइम मिलेगा लास्ट चार्ज को जलने के लिए. तो सेल्फ इग्निशन की प्रॉब्लम ही नहीं आ पाएगी. Increase the compression ratio or the load, both will increase the detonation. So A and D will be the answer. I mean 1 and 4 will be the answer. D for Delhi is the correct answer. बहुत सही अभी. Very nice. Question number 9. Which of the following statement is correct? Yes, 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 exactly, exactly. Lean mixture रखेगा नहीं क्योंकि उसमें उतना फ्यूल होता ही नहीं. Good. Yes. The which of the following statement is the correct statement? सही कौन सा इनमें से? Efficiency of the Carnot engine for the thermal power plant is high and the work ratio is also high whenever we compare with the Rankine cycle. मतलब यहाँ पे क्या हुआ है? We are comparing the Carnot cycle with the Rankine cycle. जब Carnot cycle को Rankine cycle से हम लोग compare करते हैं तो क्या result निकल के आते हैं? This is the question. One question है that efficiency of the Carnot engine is higher than the efficiency of Rankine. Second, work ratio is also high. चलिए one by one पहले एक cycle बना ले यहाँ पे. Let's draw the cycle, my dear. Okay. On this TS diagram, this cycle, what exactly we have drawn? 1 to 2 to 3 and to 4. This one is the Rankine cycle. Okay. And let me take this color. This 1 dash, 2 dash, 3 and 4 is the Rankine cycle. Sorry, Carnot cycle. So definitely this is the Carnot cycle. Efficiency of the Carnot cycle is higher than the efficiency of the Rankine cycle because of the high temperature at the time of heat supply. High mean temperature at the time of the heat supply. So the efficiency of the Carnot is higher than this, but area of this Rankine is higher than Carnot. That's why net work done in the Rankine cycle is higher. So efficiency of Carnot is higher, but the work ratio of Rankine is higher. That's why work ratio is lower in comparison to the Rankine. So B4 Bombay is the absolutely right answer, Avi. Yes, wonderful answer. Next question. Question number 10. Consider the following statement regarding, yes. Consider the following statement regarding the effect of the heating of steam in the steam turbine. मतलब he is talking about the reheating. आप टरबाइन की स्टेजेस के बीच में उसको हीट प्रोवाइड करते हो. फ्रॉम द बॉयलर it will enter into the turbine, and in the turbine, my dear, what exactly it will be happen, बार बार टरबाइन के स्टेजेस के बीच में या टरबाइन के बीच में आप क्या करते हो? रीहीट, आफ्टर दैट एक्सपेंशन, देन रीहीट, देन एक्सपेंशन. यस, it increase the specific work. If I'll draw the TS diagram of this reheating process, let's see. This one is the reheating, my dear. The first question आपके सामने है ये 1 2 3 4 5 6. I'll wait for the correct answer. First, it increase the specific output. Absolutely right, because overall area is increased. If it is not the reheating, then this is the process, my dear. It increase, yes, area increase. After that, it decrease the cycle efficiency, not at all. After that, it increase the dryness fraction, yes. If we are not going to do the reheat, this is the dryness fraction, and this is also the dryness fraction at this point. So definitely it improve the quality. So fourth is absolutely right and 2 is wrong. So fourth is right, 2 is wrong. So this is not the option, this is not the option, and after that 4, either this and this. It increase the blade erosion, no, it decrease the blade erosion. So answer is D answer. बहुत सही, बहुत सही. Wonderful. Heat supply is also increased, yes. Next. The equivalent evaporation of the boiler, producing this 2000 kg per hour of the steam with the enthalpy of this one. My dear, in this case, what exactly is happening? From H1 is how much? This 168, kilojoule per Kelvin per kg. We are producing the enthalpy whose numerical value is 2426 kilojoule per kg, my dear. Okay. After that, the mass of the steam, what exactly we are producing, that is 2000 kg per hour. So what is the equivalent evaporation? We need to check. कुछ आता है इसका, कुछ फॉर्मूला याद है सर? Equivalent evaporation is known as MS. What is the total amount of the heat we need to invest to produce the enthalpy? That is H2 minus of H1 divided by HFG as the atmospheric boiling point, that is 100 degree centigrade. So we solve it. We are getting 2000 multiplied by H is 2426 minus of 168 divided by how much? 2258. If we solve it, we are getting the answer 2000 multiplied by 2258 divided by 2258. What is the right answer? Right answer is 2000 kg per hour, my dear. A is the correct answer. A for Ahmedabad is the correct answer for all of you. Good. चलो इसको बता दो, ये तो कल भी हमने इस तरह का एक क्वेश्चन किया था. अभी the similar question we have discussed in the last class also, my dear. Given that VB is the blade velocity and V is the absolute velocity of the steam that is entering into the blade, or you can say that is leaving from the nozzle, जो nozzle से बाहर आ रही है, and alpha is the nozzle angle, then what will be the ratio of blade velocity to the nozzle velocity for the maximum diagram efficiency of this impulse turbine? We have already written in the last class that rho star will be equal to U star divided by V. It will be equal to, my dear, cos alpha by 2, or we can simply write that either U star, or here in this question it is given as like this, that will be equal to, my dear, 0.5 V into cos alpha. Okay. Very good, very good. अभी wonderful. कुछ भी पूछ लो सर, थर्मल तो बहुत अच्छे से पढ़ा. चलिए लेट्स सी, ये बताओ पढ़ा है तो. Which one of the following express the maximum blade efficiency of the Parsons turbine? In the Parsons turbine, let me tell you a few important points, my dear. That degree of reaction is 50%. In this case, V1 is equal to VR2, and in this case, VR1 is equal to V2. In this case, alpha 1 is equal to beta 2, and my dear, alpha 2 is also equal to beta 2. This important relation we are very much aware with. If we are talking about the Parsons turbine, answer is wonderful. अब लग रहा है सही में पढ़ा है, ऐसे मस्ती नहीं कर रहे हो, सही में ही पढ़ा है. गुड. क्योंकि मैक्सिमम नंबर ऑफ स्टूडेंट हम वहां तक जाते ही नहीं है, कहते हैं कि सर ये तो आएगा ही नहीं, कंप्रेसिबल फ्लो तक नहीं पहुंच पाते हैं, स्टीम टरबाइन तक नहीं जाते हैं, आफ्टर दैट कंप्रेसर तक नहीं जाते हैं. यस, एनीवे, नेक्स्ट क्वेश्चन. You have to burn the carbon monoxide, hydrogen and sulfur, and then you need to calculate, my dear, what is the amount of, what will be the amount of the oxygen that will be required to complete combustion of these all the working medium. और इसमें सबसे बेनिफिट वाली चीज ये है कि आप अगर पहले ऑप्शन को ही देखोगे, मतलब रेस्पेक्टिवली पूछा है, बिकॉज इफ यू चेक द फर्स्ट ऑप्शन तो आप कार्बन को जला के आइडिया आ जाएगा. ए, बी, सी और डी विल बी द आंसर, बिकॉज वन इज ओनली द ऑप्शन जो चारों में अलग है, तो पहले से आंसर निकल आएगा. इफ यू आर एबल टू सॉल्व ओनली द वन, यू विल बी एबल टू फाइंड द आंसर, माय डियर. पहले में आंसर आ जाएगा. लाइक इफ आई वन द कार्बन plus O2, that will be CO2. How much carbon is there? Can I write 12 kg of the carbon? That required, my dear, how much? 32 kg of O2. So 1 kg of carbon, how much it will be required? 32 divided by 12 kg of O2. What will be the value? 8 by 3. 83 kg of O2. इसके बाद कोई और चेक करना चाहते हो? चलिए, लेट्स चेक द सल्फर. S plus O2, my dear, that will be equal to SO2. How much is this? 32 kg of sulfur is required. 32 kg of oxygen. So if 32 kg of the sulfur required 32 kg of oxygen, then 1 kg of the sulfur will require 1 kg of oxygen. Answer is C4 चेन्नई. नहीं, इतना सिंपल नहीं है. प्रॉब्लम ये है 70-80% ऑफ मैकेनिकल इंजीनियर इन सबको पढ़ते नहीं है, वो छोड़ के चले जाते. तो ऐसा नहीं कि क्वेश्चन आते नहीं है, सिमिलर क्वेश्चन या इससे रिलेटेड क्वेश्चन आए हुए हैं. दैट्स व्हाई द सिमिलर क्वेश्चन वी हैव एडेड इन दिस टेस्ट. जैसे ये क्वेश्चन आया हुआ है एक बार, बताइए. The compression ratio of the gas power plant corresponding to maximum work output, my dear. Maximum work output. If we are talking about the TS diagram of the cycle, then in this case, this is the lower temperature and this one is, my dear, higher temperature. This is maximum, this is the minimum. And you want to run a cycle somewhere like this, whose compression ratio is optimum. I mean 1 to 2, 3 to 4 is optimum, my dear. Yes, like this. So आपको पूछा है what is the value in this case. We know very well that in this case नहीं T3 नहीं होता है. Let me tell you, T2 is equal to T4 is equal to under root of T1 into T3. Okay, ये होता है, या फिर इसी को max और mean भी आप बोलते हो. And compression ratio in this case, my dear, optimum compression ratio is given by T3 divided by T1 raised to gamma upon 2 gamma minus 1, where T3 is equal to Tmax. These all are the technical proved we have proved in the maximum work condition, my dear. That is our optimum. And our optimum we can also write it is under root of R maximum. और ऑप्टिमम को ही आर मैक्सिमम का रूट भी कहते हैं. ए इज द करेक्ट आंसर. यस, ए इज द करेक्ट आंसर ऑफ क्वेश्चन नंबर 15. लेट्स सी द नेक्स्ट क्वेश्चन. सर, विच ऑफ द फॉलोइंग स्टेटमेंट इज करेक्ट इन द रेसिप्रोकेटिंग कंप्रेसर. अभी एक रेसिप्रोकेटिंग कंप्रेसर है. इफ यू आर अ इंजीनियर, then on which process you want to target that my compression process must be conducted in this particular process. इसमें पूरा अच्छी तरह से मेरा प्रोसेस कंप्रेस होना चाहिए. Is it the adiabatic, isentropic, isothermally, or you say polytropic? What exactly you think in this case? आप किस प्रोसेस में चाहोगे कि मेरा थर्मोडायनेमिक वर्क या मुझे इस पर्टिकुलर प्रोसेस में ही कंप्रेस करना चाहिए? If it is the example of okay IDK. ओके, तुक्का मारता हूं सर बी, और आपका तुक्का बिल्कुल गलत है. ठीक है, चलिए, लेट मी एक्सप्लेन द क्वेश्चन. नो वरी इन दिस केस. सर, यू नो वेरी वेल, इफ आई विल ड्रॉ द पीवी डायग्राम, देन 0 to 1, my dear. If without clearance I am talking about, this one is the suction. Is it or not? So 0 to 1 in the reciprocating compressor is suction. After that I want to delivery at this point. So from 2 to 3, my dear, 2 to 3, it is the expansion process. That is the delivery pressure, my dear. So what you want to do, you want to take the air from this suction pressure and you want to deliver up to this. Now to reach from 1 to 2, you are having the 3 way. One is this one. That is the example of the polytropic adiabatic process. This is the polytropic process. And this one is, my dear, isothermal process. So this is PV raised to gamma is constant. This one, my dear, PV raised to n is constant. And the last process is PV raised to constant only. PV is equal to constant. आप समझो जरा. अब आप क्या, अगर कंप्रेसर वर्क करा रहे हो तो यू विल ऑलवेज वांट कि मुझे वर्क कम से कम करना चाहिए. रिक्वायरमेंट ऑफ द वर्क मस्ट बी मिनिमम, माय डियर. So can you please check in all the 3 processes which will require the minimum amount of the work, because compressor is the example of open system, then it will be taken as the area of PV diagram. Are you not feeling this process? This process is only require the minimum amount of the work done. What is that answer? Answer is isothermally, my dear. Isothermally is the right answer. Good, wonderful, 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 great. नहीं, पहले आपने बी मारा था तुक्का. Very important question. Yes, please solve it. A gas turbine with 2 stages of reheating, my dear. A gas turbine is there with two stage of the reheating working between the maximum pressure P1, minimum pressure P4, my dear. The optimum pressure would be, question is very important, maximum of you will create the problem in this case, face the problem in this case. जानबूझ के हम इस क्वेश्चन को टिपिकल बना देंगे. आप बताओ कौन सा आंसर आए. एक अच्छा क्वेश्चन है आपका, कंफ्यूज हो सकते हो, प्रॉब्लम में ला सकता है ये क्वेश्चन आपका. Already 20 question you have just discussed from the basic thermodynamic. 20 more question we are going to discuss here from the applied thermodynamic. Let's see कितने लोगों का आंसर बिल्कुल बिल्कुल एग्जैक्टली मैच करता है माय डियर फ्रेंड. देखते हैं. पहले मैं कुछ हेल्प के लिए आपका यहां पे टीएस डायग्राम बना देते हैं. सर लेट्स ड्रॉ द टीएस डायग्राम. टू स्टेजेस ना, सो 1 P1, 1 to 2, my dear, is P2. After that P, then from this P2, my dear, two stages are there, P1, P2, P3, right? This one is P4. P1 to P2, P2 to P3, and after that P3 to P4. Gas turbine with two stage of reheating. So these are the two stage of reheating, my dear, like this. But there are three stage of expansion. Expansion की 3 stage है, सिर्फ reheating की 2 stage है. So don't think it's a 2 stages turbine. No, my dear, it is 3 stage turbine having the 2 stage of the process only. Yes, देखते हैं कितने लोग इसका आंसर लेके आते हैं. ओ मैंने एक एरो गलत बना दिया है. Just a minute. I have drawn one arrow wrongly, like this. अभी let's see how many of you are getting the correct answer of this question, my dear. कितने लोग इसका सही आंसर लेके आते हैं, देखते हैं. बहुत आसान है, बहुत ही आसान है. एक पॉइंट पकड़ लो और ये ऑलरेडी आप कर चुके हो. फॉर द मिनिमम अमाउंट ऑफ दिस वी नो वेरी वेल दैट P2 square is equal to P1 into P3. Is it or not, my dear? And in this case we also know that P3 square is equal to P2 into P3, my dear. P4, sorry. इतना तो हम पढ़ के आए ना. P4 ये तो हमको पता है. If we write from here that P2 raised to 4, it will be equal to P1 square and P3 square. So can we substitute the value of P3 square from here? Yes. So what will be the answer, my dear? From here P2 raised to 4 will be equal to P1 square into P3 square means P2 into P4, my dear. This will be cancelled by 3 times. So P2 will be equal to this value is P1 square into P4 raised to 1 by 3. ये तो पहली लाइन का आंसर आ गया. In the first line you have checked the answer. Are you not getting Bombay? Is the correct answer, my dear? Are you not getting Bombay? Is the correct answer? सीधा तो आंसर था. Is it or not? Similarly, when you will solve this one, then answer will be equal to P3 raised to 4. It will be equal to P2 square into P4 square, my dear. If I'll substitute the value of P2 square from here, that will be equal to P3 raised to 4. P2 square is P1 into P3 into P4 square, my dear. When we solve it, this is the answer. Then P3 from here we can write like this: P1 P4 square raised to 1 by 3. देखो दो लाइन के आंसर था, आपको स्क्वायर ही करना था. And you get the correct answer in this case, my dear. So these type of simple problem आप जानते सब हो, बस कैलकुलेशन में गलती कर देते हो. You know very well all the concept, all the derivation, whatever we have discussed. But again, जैसे इसको थोड़ा बहुत ट्विस्ट किया जाता है, we create problem. We start to create problem by yourself. तब जाके कहीं फंस जाते हैं उसमें. Okay? चलिए. Question number 18 we are going to discuss here. 18, my dear. In the reciprocating air compressor, the volumetric efficiency increase with, very important concept. Very few of you are aware with the efficiency, volumetric efficiency of reciprocating compressor. पहले तो मैं आपको थोड़ा सा आंसर बता देता हूं जिससे कि आपको कैलकुलेट करने में थोड़ी सी आसानी हो जाए. That volumetric efficiency means actual volume that is entering into the system divided by swept volume by the piston. That is also written by 1 minus epsilon P2 divided by P1. P2 is delivery, P1 is suction pressure raised to 1 by n minus of 1. अब बताओ, ये होता है volumetric efficiency formula, my dear. This one is all about the volumetric formula. Whenever you need to find when volumetric efficiency will increase, it is not possible by this. ये तो हो ही नहीं सकता. The point is, मैं वही टॉपिक ले रहा हूं अभी जो हम इग्नोर कर देते हैं. और ESC अगर लिखने जा रहे हो, PSU लिखने जा रहे हो, वहीं से फोकस करके क्वेश्चन आते हैं जानबूझ के. अदरवाइज व्हाट कैन आई डू? मैं आपको स्टीम टरबाइन के क्वेश्चन दे दूंगा. H1 इज गिवन, H2 इज गिवन. आई विल गिव यू द like Rankine cycle, like IC engine efficiency, like IC engine efficiency, IC engine work done. तो ये तो आपने गेट में अच्छे लेवल पे कर लिए होते हो कि इन सब पोर्शन को हम पढ़ के नहीं जाते कभी. क्वेश्चन बहुत आसान है. So if the P2 will be decreased now, this P2 will be decreased, my dear, then definitely efficiency will increase. And in multi-stage compressor, definitely efficiency also increase. What is the answer? 2B. Multi-stage compressor is nothing but you are going to control this P2. आप इस P2 को ही कंट्रोल कर रहे हो. एक लिमिट से बाद में बढ़ते नहीं देते, उसके बाद में आप दूसरा कंप्रेसर लगा देते हो. So yes, B is the right answer. Next, चलो नया क्वेश्चन for you. If you say that why we are adding the psychrometric, compressor process, chaliye, in this part, my dear, we have added the next question that is purely related to the portion of psychrometry. चलिए अब बताइए. In the psychrometric chart, relative humidity lines are horizontal line, straight inclined line, from left to right, vertical line, or the curved line. What do you say? Like if this RH is equal to 100% in this case, it is a specific humidity. This is tribal temperature. This one is WBT, like constant WBT line, like this. And this one, my dear, is RH line, like this. This one is RH line, RH line, RH line. Curved line. When the air is passed through the insulated chamber, having the spray of the water, means there is one insulated chamber like this, and over this chamber, within this chamber, there is the condition of the spray of the water. This is a completely insulated chamber. The air is going to enter in this insulated chamber like this. Cold air is entering into this insulated chamber, and the temperature higher than the dew point temperature of entering the air, means dew point temperature entering the air. So what this water is entering now, that this T3 temperature is equal to TDP1, greater than TDP1, but lower than the dry bulb temperature. But lower than the dry bulb temperature means it is higher than dPT but lower than dew point. So what will be the condition? Is it cooled or dehumidified? Not at all. सर वाटर, एक बात बताओ, स्प्रे हो रहा है तो डीह्यूमिडिफाई का कोई ऑप्शन ही नहीं आता. ए एंड डी विल नॉट बी द आंसर. ए और डी तो हो ही नहीं सकते. ए एंड डी इज नॉट द आंसर माय डियर. डू यू नो हीटिंग कब होता है? यस दीपक, लास्ट क्वेश्चन पे आए हो बिल्कुल. बी इज द करेक्ट आंसर. आप कह रहे हो वी नहीं हो सकता, ए नहीं हो सकता, वी इज द करेक्ट आंसर. डू यू नो सर व्हेन द स्प्रे वाटर टेम्परेचर इज लेस देन, दीपक हाउ वाज द पेपर ऑफ गेट एग्जाम? तो मिले नहीं उसके बाद, कैसा पेपर रहा? T3 your temperature is lower than the dry bulb temperature or more than the dew point temperature, then it is the example of cooling process my dear. लेकिन अगर ड्यू पॉइंट से भी नीचे चला जाए ना तो वाटर वेपर जो होती है ऑलरेडी एयर में मिक्स, उसको सेपरेट करना स्टार्ट हो जाता है, ये कंडेंसेशन स्टार्ट होता है. दैट इज द एग्जांपल ऑफ डीह्यूमिडिफिकेशन. बट अगेन दिस इज मोर देन ड्यू पॉइंट टेम्परेचर. दैट इज द एग्जांपल ऑफ ह्यूमिडिफिकेशन एंड द कूलिंग माय डियर. सो कूलिंग एंड ह्यूमिडिफिकेशन इज द आंसर. हीटिंग एंड ह्यूमिडिफिकेशन इज नॉट द आंसर. फॉर द हीटिंग ओके मिक्स एक्सपेंस, चलिए वो तो और 15-16 तारीख में आपको 2-4 दिन के बाद में एक आइडिया आ जाएगा, डोंट वरी. So B is the correct answer of this question. अभी B is the correct answer. तो I think आपका ये हमने पोर्शन पूरे कर लिए. अभी तो फुल एनर्जी के साथ में दीपक गो फॉर द ESE एग्जाम. 2-3 दिन और बचे हुए हैं, उनको जरा सही से लिखो. कल क्वालिटी एंड स्टैंडर्ड एंड क्वालिटी का आपका मैराथन है. अगर आपको सही से प्रैक्टिस नहीं किया हो, यू कैन ज्वाइन द सेशन टुमारो इन द मॉर्निंग 10 AM माय डियर, राइट? आफ्टर दैट I'll share all the PDF of this class in my Telegram channel. Okay. तो चलिए see you tomorrow in the next class. Thank you all. Take care. Bye bye. And just अच्छे से मेहनत करिए इसको. चलिए मिलते हैं फिर. ओके ओके. अभी तो आप रतन से पढ़ लो. It's also a good book. Yes, Angel is also best book. Thermal HMT तो बहुत ही अच्छी बुक है.